All right, so I'm going to run through section 8.4 here with you. 8.4 should be pretty simple because it's basically everything that we already did in 2 dimensions is basically in 3 dimensions now. The only thing that you'll have to get used to is, drawing something in 3 dimensions, which you don't have to do a lot. You don't have to be great at it, but, just semi-okay at it. So, things like component form, graphing a vector, basic operations like adding, subtracting, multiplying by a scalar, magnitude, all these things I have listed here can all be done in 3 dimensions versus what we've already done in 2 dimensions. The only thing I want to add on here is the unit vectors here. So, the unit vectors before you had I was 1 and 0. Well, now you have to add a third number, 0, for the third dimension. J would be 0, 1, but you had to add a 0 there. And then the third one is K. So K is basically like your z-axis, and that would be 0, 0, 1. So when you see IJK, that's what they're standing for in these problems. So frequently when you have to draw these things on your own, I'll do that in the next page, but I have some examples down here. So like this one right here in the middle, I have 2, 3, 5. So that means that you are going, let's see, 2 in the x direction, so you're coming out this way 2. You're going 3 in the y direction, so you see that way 3, and so that's why they're meeting right here, but then you have to rise. So your xy axis is kind of like the flat surface, and then your z is like your height in a way. So if you're looking at the corner of a room, like the floor is your x and y axis, and like the corner moving up to the ceiling is like your z axis. And so you see this thing is traveling upwards to put you there. So if you're going to draw a vector in component form, 2, 3, 5, and you draw it in standard position, then you would be drawing a vector that starts at 0, 0 and goes to that point, goes in that direction. So that would be that vector. And here, over here is just another example. This is 3, 4, 5. So it's gone over here, 3, then 4, and then up 5. And, if the z is negative, you go down instead. So this right here is just kind of like a blank version of it. So let's say I wanted to graph the vector, I don't know, -3, 2, and then -4. Okay, so I go -3 in the x direction, so it would be back here at -3, then +2 in the y direction, so over about here, because I was basically where those two things meet, and then I'm going to go down 4. And so it's not going to look very good, but, down 4 I'd have to imagine is about like from here to here, down 4 spaces. So I would draw that vector right there. All right, so it's not going to be great or anything. We can't draw 3D on 2D. It's not very easy to do. All right, so here we're going to calculate some things that we've done in 2 dimensions, and now we're just going to have them in 3 dimensions. So, I'm giving you these 2 points, A and B. I want to find the following things, the component form of vector AB. So A is my initial point, B is my terminal point. I'm just going to subtract them to get the component form. So remember, I do the B minus A, the end minus the beginning here. So -5 minus 2 is -7. Then 1 minus -4 is 5. 1 minus -4, yeah. And then -2 minus 7 is -9. So it's as easy as that. You just have a third thing to do. If you're going to put something in standard form, then you would put I, J, and K. So vector AB right here would be -7I plus 5J minus 9K. So it's just basically the form change from there. All right, here, calculate the magnitude of AB in letter C. So the magnitude is just the square root of the component pieces squared. All right, so I have -7 squared plus 5 squared plus -9 squared. And you can drop those negatives because they're just going to square out anyway. Oh, so let me see, 49 plus 25 plus 81. So let me pause for a second. All right, so that adds up to 155. So inside there I have the magnitude of AB is the square root of 155. And let's see, that divides by 5. It gets me 31, so it doesn't reduce to anything. So if you can reduce it, you should, but that one doesn't. All right, letter D. Letter D says a unit vector in the direction of AB. So remember, with a unit vector, you keep the original vector, -7, but then you divide it by its own magnitude. So divided by radical 155. And then I would have 5 over radical 155. And then I'd have negative 9 over radical 155. So what that does, it maintains the direction, but it basically makes the length of that vector. Like if you did the magnitude of this vector right here, it would be 1. All right, so graph the vector AB. So I have this thing, let's see, negative 7, 5, negative 9. So I'm going to draw some axes. So the way that you usually draw things with 3D, or at least the way I do, is I make a little triangle like this, and then here, and then here. So it's usually my X, my Y, and my Z. That's just how I do it. And if I want to go back, I do a little dotted line for some negatives, Y going that way, and then Z going down. So it's not going to look that awesome, but we're going to try and do negative 7, and then 5. So negative 7 would put me back here. 5 would put me about right there. That's maybe a little short. And then negative 9. So basically that corner right there, and then down 9. So I'm going to go down here. So I'm just going to estimate that that vector looks like that. You know, like I said, it's not going to look good, but I went back 7 over 5 and down 9. And so this should be the point, negative 7, 5, negative 9. Because my vector is in component form, standard form. All right, so letter E, find the midpoint of the segment for AB. So just like with midpoint with 2 points, you did midpoint with, you have a third number. So the midpoint is where you add them up and divide by 2. So for my A and my B, I have 2 plus negative 5. So the middle would be, add those up to get negative 3 over 2. And then the midpoint of the Y values, negative 4 plus 1, so it'd be negative 3 over 2 again. And then 7 plus negative 2 is 5. So 5 over 2. So that's the midpoint of those places. So basically, you got your 2 points in space, and then the line between, it's the center, like the midpoint of those 2 places. Okay? And the length of segment AB. So just like you did the distance formula before, you now have a distance formula with 3 parts. So your distance formula used to be a big square root, and you had x2 minus x1 squared, plus you had y2 minus y1 squared. Well, now you have a z2 minus z1 squared. All right. And I'm hoping that some of you can already know for me that we have this distance answer up here already, so maybe be thinking of that. All right, so I have a big square root, so x2 minus x1. All right, so here's x2, x1, negative 5 minus 2. Oh, it's negative 7. I'm squaring it. And then y2 minus y1, so I'm getting 1 minus negative 4, which is 5. So 5, and I'm squaring it. Do you notice what this is? This is just the same thing as the magnitude, because that's the distance. That's the length of the vector. And so the last part's going to get me negative 9 squared. So if somebody asks you the distance between 2 points, it's like doing the magnitude of the component form. So this is the square root of 155 again. Okay. All right, moving right along, just a little bit more. So I'm given these vectors now. So I have 2 of them in component form, and this guy right here in standard form. So I'm just going to sketch each one. So vector A, let's see, 3, 1, 0. So I'm going to go forward 3 to about there, then over 1, and then nothing. So here is my vector A. All right. So vector B is negative 4, 2, and negative 5. So negative 4 puts me right about back here. 2 puts me, oh, I'm sorry, oops, wrong way, sorry. Negative 4 puts me about back here. 2 puts me over there probably, and then negative 5, so I'm going to look like I'm going down. So there's going to be my B. And one thing to mention, if you're in 3 dimensions and there's a 0, it'll just be missing. Like if you wrote this vector right here, you would write A equals 3i plus 1j. So if the third one's missing, it would be considered to be 0. So just something to note. All right, and then C. So C is 0, negative 6, 4. So nothing back and forth. Negative 6, so about here, and up 4, so about there. So I'm going to go to right there. And my measurements probably aren't awesome, but there it is. There's vector C. All right, so now for this next part, we're going to calculate each one. So just like we did with our 2-parters, our 2 dimensions, we have it in 3 now. So I got 4, and here's A is 3, 0, 3, 1, 0. Minus 2 times B, well, B is negative 4, 2, negative 5. So, you know, component form is like kind of the easiest thing. So let's see, I got 12, 4, and 0. I'm subtracting. Multiply that 2 through, negative 8, 4, and negative 10. All right, so to subtract, you get 20, 0, and 10. All right, for part 2, I have a dot product in there. So I'm going to go ahead and do that first. That dot product, remember, produces a single number for an answer. So 3c, so 3 times the vector c would be 0, negative 18, and 12. I'm dotting that with b. So b is negative 4, 2, and negative 5. All right, so I'll do that answer first, and then I'll get 2a in there. So 0 is my first thing. I'm multiplying 0, negative 4, plus then negative 18 times 2 is negative 36, plus 12 times negative 5 is negative 60. All right, so this is negative 96. So I have negative 96 times 2a. Well, 96 times 2, that's 192, right? So I have basically negative 192 times a. All right, well, that's gross. I didn't think about this very good. So I have negative 192, and then vector a is 3, 1, 0. So that's not that bad. But 192 times 3 is 576. So I get negative 576, comma, negative 192, comma, 0 for my final answer there. So usually it won't be that bad. All right, so for the third thing here. Third thing, I have what's written as the magnitude of c. So the magnitude of c, I just got to do the square root. It's already in component form, so I just got to square those things. So 0 plus 36 plus 16. So that is the square root of 52. 52 is 4 times 13, so that'll be 2 radical 13. Final answer. All right, and the last little bit here. So back in geometry or even in algebra 2, you studied circles and you had equations of a circle. So hopefully that reminds you right here, all that. And so now you just have a third dimension. So when you have a third dimension, then you have a sphere. So usually, you draw a circle, you put like a little loop there and maybe a little dotted thing going back. You have the center, and my center is H, K, and L. So H, K, and L. All right, and then you have your radius right here out to the side right there. So there's that formula. So just have like one extra part to it. All right, so for my last example here, it says find the equation of the sphere where these 2 points are the endpoints of the diameter. So these 2 guys are the endpoints of the diameter. So I need to calculate their center, so I can find the center of my sphere. So I'll do that first. So the center would be the midpoint of these 2 things. So the midpoint, I'd have to add them up. So my midpoint, add them up and divide by 2. So the first part, I get 8 over 2, which is 4. The second part, I get negative 3 over 2, which is negative 3 over 2. And the last part, 5 plus negative 1 is 4. 4 over 2 is 2. So that's the center of my sphere. So I'm ready to start. So I got x minus 4 squared plus y. I would write minus negative 3 halves, but that's plus 3 halves. And you can write 1.5 squared. Plus, then we have z minus 2 squared equals, I need my radius squared. So for my radius, you can do one of 2 things. You can find the length of the diameter and divide it in 2, and then that's your radius. Or, I have my midpoint sitting right here. So why don't I just find the distance between these 2 points, and then that'll be my radius. So I'm going to do that. The square root, I got 6 minus 4 is 2 squared. I got 1 minus a negative 1.5. So 1 plus 1.5, so plus 2.5 squared. And then negative 1 minus 2, that would be 3, negative 3, but basically 3 squared. Okay, it doesn't matter if they're negative. All right, so I got 4 plus 2.5 squared is 6.25, and then plus 9, so 13 plus 6.25, so that's 19.25 square root. All right, so remember on the other side of the formula, my radius has to be squared. Well, this is the radius because it's the distance from the center to one of the outer regions or outer edge. And so I need to square that. So for my formula, for my sphere, let's see if I move that over. Good. My formula, I need to have r squared. So if I square this, basically the radical goes away. So 19.25. All right, and there is the sphere that has those two endpoints. All right, and you got your homework there for section 8.4, and I'll see you later. Bye-bye.